The microalgae, or the phytoplankton, which is the base of the food web in the ocean, is what we feed to zooplankton. In this case, it's the queen conch larvae during their larval stage, which is the next stage up in the food web. So we mimic that here in our microalgae culture facility. We consider this the heart of the hatchery. If you have very good quality microalgae, you're going to have successful larval culture. So how do we start this? We have to start at least 1 month in advance of when we start to hatch the larvae. And so we end up starting off with algae that's on what we call a slant. We take an inoculating loop and we put some of the algae cells that are on this slant into a test tube. The test tube has media into it, and then it begins the process. The other way to start is by having a test tube that's already been inoculated, and this can arrive from any place in the United States that grows microalgae for shellfish hatcheries. So once you bring the test tube down, you let that grow up and acclimate to your environment here in the hatchery. One test tube gets inoculated into one flask. This is a 125 milliliter flask. So once you inoculate with one test tube into a flask, this flask then gets inoculated into the larger 1 liter flask. Each of these stages can take anywhere from 5 to 10 days, depending on your hatchery, depending on the light source, depending on the environmental factors such as temperature, depending on the cell count and your media. From the 1 liter flask, we can go larger. We can go to 5 gallons, or we can go to something as large as what's behind me here, which is a sun tube, 95 liters. So what we're talking about here is staging up, 1 stage at a time. And it takes 1 month to get that staging going and to be able to multiply enough. In this particular hatchery, we need 7 of these a week, 1 a day, to feed the larvae. And so that's how you set the stage in order to build up the microalgae that you need to be able to feed your larvae. Our hatchery manager, Victoria Kassar, is here to start the swirling today. Good morning.
Good morning. As Megan mentioned, we're going to be swirling today, and normally we do every single one of these in the morning and also in the evening. For now, I'm just going to give you an example. So I'm going to start with the test tubes, and then the smaller flasks, and then the larger flasks. You can see how settled the microalgae is at the bottom of this test tube, and that's exactly why we need to swirl them to make sure everything's in suspension. So the first thing I do is I tighten the cap. I give it a nice swirl. You can actually see it starting to move. Then I loosen the cap again. This allows for aeration, and I put it back into the rack. We do the same thing with the other flasks. Same idea, we want whatever has settled at the bottom to come up into suspension. And the goal is to create a little vortex. Like that. And lastly, with the 1 liter flasks, we go in both directions.
We're about to make media, and what that means is that we're adding nutrients to seawater to be able to grow the microalgae. So the nutrients are a combination of your nitrates or your phosphates, and also your trace minerals and your vitamins. And for the Catossaurus, we also have to add something called silicates. And so we prepared the seawater, which Victoria's going to take you through the steps here. So we're essentially preparing the media so that tomorrow we can do what we call transfers or inoculations. You always have to prepare your media 1 day ahead of your transfers. So that's what we're about to do today.
What we've been referring to as the media is kind of like fertilizer, and so we add that ahead of time into our flasks so that when we put the microalgae culture in it tomorrow, it'll be able to grow really nicely. This is a very concentrated solution, and we've calculated exactly how much needs to go in here. So for 3 liters of seawater, we will be putting 1.2 milliliters of this concentrated media solution. This pitcher right here is 2 liters. And this is seawater that we've filtered through our filters as well as the UV filtration system. And this was 1 liter.
Now that Victoria has filled this media container with exactly 3 liters, she's going to take a 1 ml pipette out and put it inside of the media. Usually there's some settlement in the bottom of this. You can actually see as Victoria is stirring it, you can see that a lot is coming up from the bottom. So we spend just a minute or so just trying to get that nice and stirred up. So this is a 1 ml pipette, so Victoria will bring up 1 ml first and then the 0.2 on the second round.
Okay.
Okay. Then you can run your salt water up and down through that to get anything that might be remaining in the pipette. It needs quite a good mixing because it's such a small amount of media that's going in there. You really want to make sure it's mixed well.
In order to know how much of this media solution to make, we calculated ahead of time. We looked at all of the vessels that we wanted to fill and calculated the amount of milliliters in each. For these larger 1 liter flasks, we decided that 800 milliliters was a good amount. That way when we swirl it, we're able to really get the microalgae culture to swirl, versus if it was filled to the top, it'd be really difficult to do.
So Victoria is about to pour 90 mils for these small Erlenmeyer flasks, and then tomorrow when we do our transfers, we'll put 10 mils of microalgae. And so that way there's enough room for the new microalgae, and the ratio of media to new transfers is the right ratio. Now we're ready to sterilize these using the microwave. So now that the media has been prepared in our glassware, we need to sterilize it. And so the best way to sterilize it, especially when you're in a small hatchery in the Caribbean islands, is to use a microwave. A regular microwave. The only thing that you need to take into consideration is the height of the microwave to make sure that the flask will actually fit inside. So it does fit inside. That's the isochrysis. And then this one is the one that has the silicates in it for the Catastris. So we can do 2 at a time in here. It's 7 minutes for this amount of liquid. We'll do a 5-minute first, and as it's getting hot in there, then we switch it for the last 2 minutes. We'll do the same with the flask. The flask will go in next, and there'll be 6 of them, and then we do about 3 to 4 minutes for the flask. Really what you're trying to do is get them where they come to a boil, and then you know that they've been sterilized. And so all the algae that we've been working with has been going through that process, so it's a very efficient way. The other method is called an autoclave, and that's really quite a big, elaborate piece of equipment for a hatchery that's in the Caribbean, so we do recommend the microwave. We have 2 more minutes to go. I'm switching them around in place here. And then by the end of the 2 minutes, they'll be boiling. Okay, so you can see that they have condensation in the top, so it's come up to enough heat Also, when we first opened the door, there's a little bit of bubbling going on. They're very, very hot at this point. So I'm going to use these oven mitts and very carefully remove them, holding on to them very tightly and transferring them over to this area here. That way they can cool down overnight, and then we'll be ready for transfers in the morning. This time we have enough room to have the turntable in here. So we'll put 6 in here at a time. This will be 4 minutes. Okay, we have just a test tube left, and they take less than a minute to do. So let's go ahead and put those in the microwave. I'm just going to double check that the caps aren't too tight, because they can essentially explode if the caps are on too tight. And they go in the microwave. We will set it for 30 seconds. And there we go. Okay, they're boiling now. You can actually see it in here. One thing you don't want to do is you don't want to seal the test tube caps tight on here, because when they're hot, it will make a vacuum. And so you wait until tomorrow, and then when they're cool, you put them back on tight again. We're going to do transfers from the test tube to the test tube. One of the things that's really important about the test tubes is that they're the beginning of the cycle for growing microalgae. We always talk about the parents, and then we talk about the children, and we talk about the production line. So each time we take out of the children or the production line, we have to start new children down the road. So essentially it's a generation thing. And what is best is to have 3 generations of microalgae. And so for instance, these ones are 612, and these ones over here are 623. We happen to have a 618 in the mix, and today we'll be making a 79. So we'll have 3 generations of microalgae. This becomes a backup. If there was some reason that when you were doing transfers, the microalgae did not grow, you can always go back to the later generations that you know are doing really well. And so the test tube stage is one of the most important stages of making sure that you always have generations of microalgae available for you as you work down the line. So I'm going to start by first just putting the date on these labels. We remember that we have silicates in here because we're working with Conservación now, which is a diatom. Today's date goes on the test tube label. Just go right down the line and do this. Okay, you can also see that the algae that we're going to be transferring into the new vessel is right next to it. So algae, new media, algae, new media. And so each one is going to be used. So keeping organized like this helps you to remember which one you inoculated into. So we're going to go ahead and start now. We're going to start by having our alcohol burner lit. We need that flame to help keep the bacteria down from our transfers, making sure that we keep as clean as cultures as possible. So we're going to take this first test tube, tighten the cap, give it a swirl, put it back in here, make sure that the receiving vessel is also loose. And then we're going to take our pipette. Our pipettes have been cleaned using the microwave as sterilization. Once again, we keep our fingers just down towards the end and put the pipette bulb in. We keep it near the flame. So in this case, I'm going to take the test tube, go in, take a sample, flame again. Keep my algae near the flame, not in the flame, or else it would kill it. Take the next one, go right down the middle, flame, and the test tube cap back on again. We do that 2 times because we need 2 mils. Take a sample. Take the next one. Flame right down the middle. Flame. And that one is complete. And then this pipette is a used pipette, so we set it aside and we get a new one as we need it, and then we continue the process some more.
The first step is to light the alcohol burner. And in this series, I'll be staging up from a test tube to a 125 milliliter flask. As always, the first step is to swirl. I can put this cap down because we won't be using it again. Flaming the lip. Flame, flame, transfer, flame, close.
Okay, so we're about to do what we call transfers or inoculations of scaling up the microalgae. And today Victoria is setting up her station here. You can see that she has her alcohol burner. She's got her 25 milliliter Erlenmeyer flask. She's swirling it before we do the transfer. We want to make sure that everything's in suspension. And she's taking the 1 liter flask. So we take one 125 milliliter flask and we inoculate it into one 1 liter flask. So the first stage is to swirl the algae first and then to remove the cap. We no longer need that cap. We flame the mouth of the 125 milliliter flask, flame the mouth of the 1 liter flask, flame the mouth again, and then we do the transfer. Very nice. And then we do one more swirl, make sure that the new algae cells are well mixed into the new culture media.
An important part of this process is to label all of your vessels with the date of inoculation so you can keep track of the growth of the phytoplankton and its age so we know when to feed the veligers.
In the morning time, after we've done our routine with the swirling of the algae, we then choose an algae flask that's ready for feeding to the veligers. So we always do the feeding in the morning time. We first have to do a cell count because the amount of feed that we feed the algae is based on the age of the veligers that we have in the tanks. So the first thing we're going to do is Victoria's going to bring me a flask, the flask that we selected, and I'm going to take a sample out of it. Thank you. So this is our flask from Isocrisis, and it was inoculated on June 23rd. So we need a couple of tools in order to do cell counts. We have our own box here that is labeled cell count so that we can always find exactly what we need. Inside this box, we have a counter, a hand counter. We also have what we call a hemocytometer, which is used for actually counting blood cells, but it actually works really well for counting algae cells. We have a lighter that's used to light the alcohol burner so that we can take a sample, a pipette bulb, and then we have these containers that are labeled, and this one is ISO 1. We're only looking at one flask today. Okay, so the next step that we do is we light our alcohol burner. And so a simple lighter here, you can see the flame The flame does get affected by the air conditioner, and it's best when we're doing cell counts to turn the air conditioner off just for a couple minutes. That way we keep everything in this area without air circulating and helps to keep down any contamination. So Victoria, if you wouldn't mind turning the air off just for a couple minutes. Thank you. Just let that air kind of settle down. Okay, we have our flame here. The next thing that we do is we take the flask and we swirl it. And we need to do that in order to make sure that it's good number of cells suspended equally throughout the sample. So it's actually just like the swirling that we do in the morning and the afternoon. It's the same. Sometimes I get a little bit more of a swirl because I really want a good uniform sample in the flask. Then we're going to reach in. We're not going to take the cover completely off. I'm going to try to touch only one pipette and bring it out. I keep the pipette near the flame, not in the flame. You do not put your fingers below this little ridge here because you don't want to take any contamination that's on your fingers into the flask. Now I'm going to flame it once. That keeps the bacteria away. Using my pinkies and my other fingers on this hand, I'm going to grab the cap, flame, take the sample out, flame, put the cap back on, and then I have my sample in my pipette and I put it into the sample container. And then I turn off my alcohol burner and we can turn the air back on. Okay, so now we have our hemocytometer. It has a special cover slip. And this cover slip is made exactly for this hemocytometer. You put it on so that the two little wedge areas are open. It's also the right weight, and so the reason for a hemocytometer is because we know the volume of liquid that's going into the hemocytometer. And then we take our pipette that we just used and we go back and forth to make sure that our sample is mixed. And then we take a very small sample, and with capillary action, we just fill the cell. So there's one, and then I'm going to do the other one. There we go. And so it's capillary action, and then it's full. So the next step is then to put the hemocytometer very carefully on the stage of the compound microscope. We always start at the lowest setting, which happens to be 40 times the size of the cell. And then we go up to 100 times the size of the cell. But the lower setting allows us to focus, and then we can go up higher and get an even closer look. So I'm just going to put this a little closer to myself and take a look and see what we have today. Turn on the microscope. So we're looking for a couple of things when we look for algae. We're looking to make sure that the cells are mobile, because it is a mobile microalgae. It's a golden brown flagellate. And we're also looking to see the cell count. We're looking to see that it's a pure culture, that it doesn't have other things in it besides the algae that we're growing. So Victoria is able to see what I'm seeing on the phone, so she can see what we have here is we have these grids, and there's 25 of these big squares, and inside each of those there's 20 smaller squares. We don't worry so much about that, except let me just go down and power a little bit so you can see a little bit more of the frame. And I'll just get this so it's a little straighter. There we go. And we'll move that just the stage just a little bit. So there you can see all 25 squares, 5 across and 5 down. And all the little dots that you see in there are the microalgae. You can see a few of them swimming around. Sometimes when you're loading the hemocytometer, they actually might stop moving. So you definitely want to see some movement in there. It's best to see, at least 50% of them moving around in there. So in this case, I'd probably want to load another hemocytometer so that I can see more movement. But since we have such a good sample in here, we're going to go ahead and count it. So what we're going to start with is this square here, and then we're going to keep moving over, and we're going to count 5 squares across. One thing that we can do with this app, which is quite good, is you can actually take a photograph of what you see here, and then you can do the count later. So that's also another way that you can do a cell count. But I'm going to go ahead and use the aid of the microscope and the fact that I can move along at my own pace. Okay, we get 44 for that one.
Okay.
And I'm going to do one more count. So I set this back to 0 again, and I'm going to find another line. Now, if they're too modal to count, then you have to add one little drop of alcohol, and that slows them right down. So this one was 58.
Okay.
Okay? So we did 2 counts using the hematometer. And now we're going to do the calculations to figure out how much algae we have per milliliter of seawater, or excuse me, a milliliter of microalgae. In this manual, we have the age of the veligers and how much cells that they eat on a daily basis. And it's also based on whether or not we did a water change. So we did water changes yesterday. So they end up getting half of what they got the day before. So there's already been algae in there left over from the day before that they've been eating away at. And so today they're going to get 4,000 cells per mil of tank water. Mm-hmm. Okay. And then it's going to be the equivalent of 272 million cells total that larvae tank's going to get. And we calculated based on the size of the actual larval tank. So those larval tanks, I'm just looking over at the larval tank there. Those larval tanks are 68 liters or 68,000 milliliters. So we have our calculations here. And how much food do we feed? For day 8, we will feed 3,000. Okay, so we have completed our cell counts now. And we've calculated how much food we need to feed our veligers. So the next stage will be to actually do the feeding. So we're in a good shape right now. We've got some very healthy algae. We know how much we have to feed. And so now it's just a matter of actually feeding the veligers.
Now that we've done a cell count, we know how much microalgae to feed the veligers. So I will be pouring out that amount to feed into the larval tank. As always, we swirl. We keep this lid in the hand so that it doesn't get contaminated by placing it on any area. 105 milliliters was our calculation, and now I can go ahead and put that into the larval tank. Now that we have our microalgae culture measured out, we will put it into the larval tank to feed the veligers, and we usually do this in a circular motion to evenly distribute the food. Tomorrow, when we look at these veligers using the microscope, we should see that they have a golden gut, which means that they've consumed the golden microalgae culture.